Welcome back, Algebra 2. We are in lesson 48. We're going to talk about radical equations today. We have noted that the difference of two squares theorem permits the solution of some equations by taking the square root of both sides of the equation. For instance, we have x, let me get back over here. That is not an x, that's a plus sign. Hello. X plus 2 squared minus 5 equals 0. First, we transform the equation by adding 5 to both sides. That makes this cancel, and this becomes x plus 2 squared equals 5, right? Next, we take the square root of both sides so we can get rid of this. We square this, and we square this, which makes this x plus 2 equals plus or minus, because it could be a negative, square root of 5. Okay, now we can get rid of this 2 to solve for x by subtracting 2 from both sides. So what we end up with is that x equals negative 2 plus or minus the square root of 5. And then we can separate those. We say that x is equal to negative 2 plus the square root of 5, and that x is equal to negative 2 minus the square root of 5. So we have two different options there with our answers. We use another process to solve equations that contain a square root radical. First, we isolate the radical, and then we square both sides of the equation. This is permitted because it follows directly from the definition of a square root, which is that if x is a positive real number, then the square root of x is the unique positive real number such that the square root of x squared is equal to x. But when we do this, we must always check our answers in the original equation, because squaring both sides of an equation sometimes generates an equation that has roots that are not roots of the original. What that means is sometimes the answers don't check. So you always have to check your answers on these problems, because if you don't, one of those answers might not be true. You have to put it back in and see, is that really the answer? Does that really solve the problem? Think of it as you have solved for x and gotten two possibly correct answers, and checking verifies that either A, they are both the correct answer, or B, only one of them is the correct answer, and which one is it? So that's what we're going to start doing now. We have to make sure that we check our answers to make sure that they are correct. Okay, so let's start with, I'm going to clear the page. Make sure you write down the definition of a square root in your notes if you haven't already done that. I'm going to clear the page. Let's begin with 48.1. So we're going to solve x minus 4, or the square root of x minus 4 minus 2 equals 6. So we'll start by adding 2 to both sides, which gives us the square root of x minus 4 is equal to 8. So now we will square both sides. And we get this. We'll do this. We'll square. So this times itself would give us this, would equal this. Now we can add 4 to both sides. and we get that x is equal to 68. All right, so this is a possible answer, but we've got to check it. So let's take it back up to the beginning and sub it in here. 68 minus 4 minus 2 equals 6. So let's see. 68 minus 4, that would be the square root of 64 minus 2 equals 6. 8 times 8 is 64, so that would be 8 minus 2 equals 6, and that is correct. Thus, 68 is a solution to the original equation. All right, so we see how to do this now. We see how to get rid of the radical, but we always want to check it and make sure that that's the right answer. All right, let's do 48.2. We have the square root of x plus 4 plus 2 equals negative 7. So again, we're going to subtract 2 from both sides. Makes that cancel. We have the square root of x plus 4 equals negative 9. So we're going to square both sides. We get x plus 4 equals 81. All right. So now we can get rid of 4. And we get x is equal to 77. So now we have to check it. Let's see if this answer fits our bill. So the original equation would be 77 plus 4 plus 2 equals negative 7. That's going to be the square root of 81 plus 2 equals negative 7. 9 plus 2 is not equal to negative 7. Therefore, x is not 77. It is not true. So this is not the solution to the original equation. And we find that when this is a situation, yes, we got an answer, but it doesn't solve the problem. It doesn't give us the right answer. So what we find is that there is no real number solution. So the answer is no real number. All right, this is the answer to this problem. Or actually, I should say, with this one, it's sad because there's no real number for this. This is wrong. Even though we did everything right, you have to check to see if it actually solves the problem in the original equation. So this, when you're doing your homework, this is a real answer for you to type in. If you go back and check your work, you will have to put this in occasionally. All right, let's clear this and do another one. Let's do 48.3. We have the square root of x minus 3 minus 3 equals 5. So the first thing we do is we add 3 to both sides. This cancels. X minus 3 equals 8. We square both of these. X minus 3 equals 64. We add 3 to both sides. X equals 67. Now we have to check it. When you're dealing with these square roots, you just have to check everything. 67 minus 3 is the square root of 64. 8 minus 3. Jumped the gun, didn't I? Does equal 5. So this is correct. So it checks. All right, so you just have to check all of your answers for radical problems. And the reason for that is when you square a number, or when you look for the square root of a number, you don't know whether it's positive or negative when it's in the square root. You just don't know. That's why we've used that positive negative symbol before, because we don't know which one is which, right? So what happens, we're going to eventually get to the point to where whenever we find the solution to this, it's going to be this. And we're going to test both of them. All right, so let's move on. Let's clear the page and do 48.4. And we have here x squared plus 2x plus 13 minus 3 equals x. All right, so let's add 3 to both sides. All right, we're going to square both sides. This becomes x squared plus 2x plus 13. All right, this becomes, actually what I'm going to do, I'm just going to rewrite this here. And then I'll distribute. So that's x squared, 3x, and 3x is going to be 6x plus 9. So let's look and see what we can do. Let's subtract 13 from both sides. Let's subtract 2x from both sides. And let's subtract x squared from both sides. All right, this cancels and this cancels. This cancels and this cancels. 0 equals 4x minus 4. So let's bring this 4x back over and subtract 4x from both sides. We get negative 4x is equal to negative 4. X is equal to 1. Oh goodness, let's check that and see. Let's put it back in the original equation. All right, so our original equation was x squared plus 2x plus 13 minus 3 equals x. All right, so let's put 1 in for all of the values. So we have the square root of 1 squared plus 2 times 1, which is 2, plus 13 minus 3 equals 1. 1 plus 2 is 3, plus 13 is 16. Square root of 16 is 4 minus 3 equals 1, and that is correct. So this is indeed the right answer. Seems like a long way to go to get the answer 1, doesn't it? All right, so now you guys see how to do these. Isolate your radical on one side by subtracting or adding and moving everything over. Then you square everything on both sides. Then you solve for x. Then you check and see if x is actually the solution that you solved for by subbing it back into the original problem. And then that will tell you whether the answer is no real number or if it is what you found. And then whatever you found to be the correct answer when you checked, that is what you type into the system for your answer. Okay? All right. That is all I have for lesson 48. I'll see you guys in lesson 49.